Today, we'll discover if aliens have crash-landed in the ocean, and in our Shark Bite, we'll discover gravitational holes in the sea.
You're listening to the Shark Week podcast.
G'day and welcome to Shark Week, the podcast. I'm your host, Luke Tipple. Now, before we get too deep into things, make sure you subscribe to this channel, like the video, and ring that little bell so you never miss another one of our weekly episodes. You know, I think what drives many of us to the ocean are two things: adventure and discovery. Think about Charles Darwin's journeys to the Galapagos Islands to find new wildlife, or the explorers you learn about at school who had little more than a ship and the stars and a sextant to guide them around the globe. I mean, isn't that crazy? Behind each of these crazy, often adventurous and dangerous expeditions was always discovery, a desire to find out what's over there. And that's still true to this day. I mean, how many Shark Week specials are based on the idea of going on an adventure and finding something new? It's absolutely baked into the brand of these shows because it's baked into us as scientists. We want to discover, to know more, to learn more. And how much more is there lying in the ocean that remains completely unknown? Well, today's guest went to the ocean, not to discover sharks or new lands or a shipwreck, but to find evidence of extraterrestrial life. And he's not some tinfoil hat in the scientific community. This is Dr. Avi Loeb. He's a Frank B. Baird Jr. Professor of Science at Harvard University, and he's the director of the Galileo Institute. I mean, this guy is the man. He's authored and co-authored over 1,000 scholarly articles. He's a New York Times bestseller writer of Extraterrestrial, where he argued that our solar system was likely visited by alien tech within the last decade. And he's here because he recently led a deep-sea expedition to find the remains of an object called Oumuamua, which was classified by the United States Space Command as an interstellar object, meaning one that came from outside our solar system. Oumuamua crashed into the ocean in 2014, and Avi went to find out what it left behind. And according to him, he discovered what may be the first evidence of life outside of Earth. So Avi, welcome to Shark Week, the podcast. I really appreciate your time. Now, when I was a kid, I always wanted to be Jacques Cousteau. I've told this story many, many times on this podcast. I, pursued marine biology and did all that. But what I haven't said to many people is that in my teenage years, I really, really wanted to be Fox Mulder. I recorded all the X-Files on VHS. I watched them multiple times. I was so enamored with the idea of there being extraterrestrial life that I was determined to move to America, become an FBI agent, and start investigating UFOs. That never happened.
It's never too late.
Maybe. There's a definite opportunity for me here. But since I have you here, let me lead off with the most pressing question. Do you believe that there's extraterrestrial life?
Well, thanks for having me. I think it's arrogant of us to believe otherwise. It's sort of like staying at home and looking around and saying, I don't have a partner. But we all know that to find a partner, you need to go to dating sites and you better look through your windows or at least go out to the backyard and search for objects that came from the street that might tell you about your neighbors. And when Enrico Fermi, the physicist, asked, where is everybody? Without seeking anybody, just sitting in Los Alamos, that's not a good question. That's not a productive question. Also, when people say extraordinary claims require extraordinary evidence, that's some statement that Carl Sagan repeated. That's also not a good statement because we should say extraordinary evidence requires extraordinary funding. We should seek the evidence. And by the way, that's the way science is done in the mainstream. We don't know what most of the matter in the universe is. 83% of it is of a substance that we've never witnessed in the solar system. So we don't know what it is, and we invest billions of dollars trying to search for specific ideas that some scientists had about the nature of dark matter, like supersymmetry as a new symmetry of nature that could account for a dark matter particle, and the Large Hadron Collider was funded at $10 billion to search for it. And guess what? It didn't find it. Nobody says that was risky, that was a speculative idea, that was an extraordinary claim that we shouldn't have pursued, because that's the way science is done. And what do we know about us? We know that we sent out 5 probes to interstellar space over the past half a century, and we know that other stars have planets the size of the Earth, roughly at the same separation, and there should be billions of them in the Milky Way galaxy alone. And we know that most stars formed billions of years before the sun. And we also know that it takes less than 1 billion years to traverse the entire Milky Way galaxy with chemical rockets of the type that we launched. So you just add all these facts and you say, okay, we exist, others could have existed before us. Let's just check. And what have we done? Instead, we said, okay, we'll wait at home for a phone call. Let's listen out for any radio transmissions. For that, you need the counterpart to be active, to send you or to call you.
And to be also in that same frame of mind to be sending out their own radio or to be listening to radio and assuming that they're even attuned to the same idea of radio, right?
Yeah, the other thing is there is no way to have a conversation because it takes thousands of years for the signal to cross galactic distances. So what's really the point of a phone conversation that we don't know if anyone is calling us? And if anyone would be calling us, we won't be able to have a conversation. But that's what we've been doing for 70 years, believe it or not. And moreover, the people who have been doing that are very hostile to alternatives. They say everything in the sky must be stones. I call that the stone age of science.
Yeah,
and
that's fair.
My point is, when you go to the backyard, there is a chance you would see a tennis ball thrown by a neighbor. Just allow for that.
So there's two separate events that you've been involved in recently. One was this object in 2017. What is it? Oumuamua? Is that right?
Yes.
Your evidence seemed to say that it could be of extraterrestrial origin. And you published the paper and then you got shut down. Is that right?
Yeah. The thing is, this object looked different than asteroids or comets that we are familiar with. And initially I suggested, well, it looked so weird. I said maybe it was manufactured technologically. And other people at the beginning was very welcoming to that. I mean, the paper was accepted for publication within 3 days. But now, 6 years later, they are going crazy arguing that it must be a rock of a type that we've never seen before. It must be a rock and it's natural, but it's of a type that we've never seen before. So I'm just like the kid in Hans Christian Andersen's tale saying, look, the emperor has no clothes. And everyone around me saying, no, it actually has clothes and they're beautiful. You just can't see them. Like it's made of hydrogen, it's made of nitrogen. So by now, we can't collect additional data. So I just said, let's leave it on the table because we can't really figure it out. But then I found a way around it because there was an earlier object, a meteor that collided with Earth. Oumuamua was roughly the size of a football field, but this meteor was about 1 meter in size. And the US government satellites detected it in 2014, January 8th. And it exploded about 20 kilometers above the Pacific Ocean.
What you're talking about, the object is this IM-1, correct?
Right.
That's
the name I gave to this object.
Okay.
It's an abbreviation for interstellar meteor number 1, the first one recognized as such. Yeah.
Okay. And what makes this unique?
It was unusual in 2 ways. It was moving faster than the escape speed from the solar system. So actually outside the solar system, it was moving at 60 kilometers per second, faster than 95% of all the stars in the vicinity of the sun. So it was an anomaly in terms of its speed, but moreover, in terms of the material strength, it maintained its integrity down to the low atmosphere of the Earth and was subjected to extreme stress and did not disintegrate at a point where all other rocks that we are familiar with would have disintegrated, would have exploded. So we know that it had a very unusual material strength, more than 272 other meteorites in the NASA catalog over the past decade. And that's why I suggested maybe it's artificial in origin. Let's go out and check. And I led an expedition to the Pacific Ocean. And the amazing thing is we found the molten droplets from the surface of the object when it was exposed to the immense heat from the fireball. And we collected them. By now we have 727 of them, roughly 1 millimeter in size, 1 milligram in mass. And we are putting them through the state-of-the-art instruments that the world has to offer, mass spectrometers, electron microscopes, and also X-ray fluorescence analyzers. The next question is, was it artificial in origin? Because the molten droplets from a Voyager-like meteor, a meteor that resulted from a spacecraft colliding with Earth, those droplets would be very different in composition than the droplets of a rock.
And how are you actually substantiating that when that's, many, many, many millions of miles away? How fast is it moving?
It was moving at 45 kilometers per second when it collided with Earth. But it actually came from behind. The Earth orbits the Sun, and it was moving roughly in the same direction as the orbit of the Earth around the Sun. So if it were to collide with Earth head-on from the opposite direction, or if you were to reverse the direction of motion of the Earth, it would have 90 kilometers per second relative to Earth. Cars in the highway, they move between 40 and 90 kilometers per hour. This object was moving the same distance in 1 second. So we're talking about 40 to 90 kilometers in 1 second.
And how would an object achieve that velocity in space?
So if it came from a planetary system, it could be a rock, let's say, then it could be ejected. But the typical speed that it would inherit in that case would be similar to the random speed of stars in the vicinity of the Sun. And what I'm saying is that it was faster than that, at least twice as fast, if not more. And one possible way for it to gain speed is by propulsion.
So if Voyager was moving that fast and it crashed into Earth's atmosphere, what would be left of it? If an object that we made, that we know that exists, if it did the same thing, would we find tiny little molecules of it?
Oh yeah, definitely. That comes from the surface, because in this explosion, we know how much energy was released because the government observed it. It was a few percent of the Hiroshima atomic bomb energy, and it was released roughly into 500 kilograms of material. So it would melt the surface of Voyager. And the question is whether the core would survive. And I think there is a good chance that some of the core would survive in the case of Voyager, because it had a very tough material that it was made of.
Let's talk about the expedition and the actual methodology that you used to collect the samples that you did. Whose idea was it to drag a giant magnet across the bottom of the ocean?
Well, we borrowed this idea from past attempts to recover spherules from other meteors that exploded over the ocean. So it was demonstrated before. Most recently, about 5 years ago, there was a mission that attempted to recover, but in much shallower water, and they were able to find some spherules there. We had a much deeper floor, which was 2 kilometers deep, the ocean floor at the location that we were. But the method is quite similar, and we learned from the experience of those people. We consulted with them, and then we built a sled that was roughly 1 meter wide. It looked different than their sled. It was 200 kilograms, and then it had magnets on both sides. So most of the material was volcanic ash. These were magnetic particles, black powder, that resulted from volcanic activity in the area. And after the 6th day, I was worried because we didn't yet separate the volcanic ash, and I asked, where are the spherules? I was looking for that. And then we used a mesh with a size of roughly 1/4 millimeter to filter out the dark powder. And then we were left with bigger particles and looked at them through a microscope. And lo and behold, found these spherules. And we found 50 of them on the ship. So together with what other people found, we have 727 altogether by now.
Tell us what a spherule is.
Like metallic marbles. They are beautiful. They have a gold, blue, brown, or black colors. The one thing that we found, which is extremely important, we went to sites that are far away from the expected meteor path just to have a controlled sample of the background. And what we see is the concentration of excess spherules per amount of volcanic ash that we retrieved along the meteor path. So you can see it very clearly that there is a big enhancement in the number of spherules per unit mass of volcanic ash that we collected in the location of the meteor. And that says that we probably found those molten droplets.
So it's telling you it came from the meteor itself.
Yeah, and not from the background. And the next step, we can demonstrate that by finding that the composition does not, does not resemble anything that is in the solar system.
So are these spherules naturally occurring through volcanic process or something just on Earth normally? Like in the background, you say, if you drag your sled anywhere, would you find them?
You can ask, okay, could there be spherules that were made geologically? The answer is yes, you could have spherules that are made on Earth. You can tell the difference between those that are made on Earth and those that come through air at high speed, because when they go through air at a high speed, there is a process of evaporation, heating to extreme temperatures. This is called fractionation. You basically lose some elements, and those provide you with a fingerprint that what you're looking at came through the atmosphere at a high speed.
So you're going to analyze these spherules. Presumably you'll find that it has elements that are not frequently available or very common here on Earth, or perhaps completely of extraterrestrial origin. How does this build a case towards extraterrestrial life?
Oh, like imagine semiconductors or computer screens being melted. You would be able to tell that they are not a rock. And that is the second question that we want to address. Is the composition of the object indicative of a technological manufacturer that cannot be easily explained as natural? That is a higher bar, but even if we just show that it's interstellar, that it's from outside the solar system, that's a historic discovery because it's the first time that humans put their hands on materials from a big object that came from outside the solar system. Never before. This is the first time. And it opens a new frontier for finding what lies outside of the solar system using microscopes, not telescopes. It's a completely new method.
Take a wild speculative guess for me at what it could have been. So if it's not a rock, right? If it's got some type of propulsion and it's traveling from another galaxy, what is it? What was it?
So there are two types of objects you can think of. The most common would probably be space trash, because just think of Voyager, Pioneer, New Horizons. These are objects we launched to interstellar space. They would exit the solar system in 10,000 years, and then they would just pollute interstellar space. They would not be functional, and they could collide with another planet and appear as a meteor, of course. But that may be the most common thing, just like plastics in the ocean. All of those chemical rockets launched by other civilizations before us, they should accumulate over time in interstellar space because they don't move fast enough to escape from the Milky Way galaxy. So they are just collecting over billions of years, but they are indicative of a technological civilization that produced them, just like plastics in the ocean. And by the way, by the year 2050, there would be more mass in plastics in the oceans than mass in fish. So when you go to a fish restaurant, just be careful after 2050.
Yeah, we've talked about that a lot here. But I mean, you're right. I haven't thought of it that way because, if there was a mass extinction event and humans disappeared and another intelligent species emerged and started dragging the oceans, they'd find plastic and therefore evidence of a previous civilization, right?
Exactly. I call that space archeology. You're looking for relics of other civilizations that may not exist anymore. And we can do it in space, just the way we did it on Earth. And to me, it sounds very plausible. It sounds like common sense. It also sounds like common sense to the public and to people in Washington, D.C. The only place where common sense is not common is academia.
What do you think of the more recent anecdotal, some will say very firm evidence of there being extraterrestrial use of the oceans, objects disappearing into the ocean or appearing above the ocean? It stands to reason that if there was an advanced race that was visiting us at some point, that they're using the oceans, right?
Yeah. Well, one thing to keep in mind is first, we don't know if it's real. I mean, there are some military personnel that reported about such things, especially the Nimitz incident. And also, it doesn't mean that they came from far away. It could be that someone preceded us in the solar system. Okay, that's another possibility, or on Earth. But at any event, last week we had a hearing in the U.S. House of Representatives, and it was attended by two eyewitnesses that were pilots who saw unusual things. One of them indeed saw these transmedium objects going into the ocean, coming out, and so forth. there was a third person who said that he is aware, after speaking to 40 people, he's aware of programs for retrieval and reverse engineering of alien spacecraft that the US government has in its possession from crash sites. And it's not so much that he said that, but more importantly, he promised to provide the contact details of people within those programs to their representatives in the US Congress. So presumably they will follow on his leads and get to the bottom of it. And if he's right, this data, these materials should be shared with scientists. I'm not waiting for that to happen because it may take a while, and it may well be that it's easier to retrieve information about interstellar space from the bottom of the Pacific Ocean than it is from politicians in Washington, D.C.
I totally agree. I guess we are, we're kind of diving into, what are we as humans and where are we going? I mean, you just wrote a book called Interstellar, and it does imagine, where humanity is going. What are you hoping people get from the messaging of the book?
Well, I hope that they will get a good sense of how transformative such an experience, an encounter with something from a neighbor would be to humanity. And my hope is it will bring us to a better place because, we are all in the same boat. That's what I realized on the ship, Silver Star. All the team members were working for the success of the mission. And we are not doing that on Earth. We're fighting each other, trying to conquer a piece of land, trying to feel superior relative to other people. That's not working together. And perhaps by finding a neighbor, we would realize, oh, wait a minute, we are all in the same home, members of the same family. We are in the same boat. Let's stop fighting with each other. Let's work together. We are part of the human species. This is really my main message. It's an optimistic message. It's a naive message, but I hope it will come true. So that's what I talk about in Interstellar. And it's very timely because we might find out that the spherules that were retrieved from the bottom of the Pacific Ocean imply a neighbor.
I would love for that to be true. I so want that to be true. Well, Avi, hey, thank you so much. I never thought I'd be sitting here talking to someone with a mind as brilliant as yours. I appreciate the research you've done. And I really do hope, when are you going to get the results of this spherules? Like, when are we going to get this next boost of media craziness that says he found it?
My hope is within a month.
Nice.
And, maybe we have something already, but I will not tell you.
Okay. So you heard it here. Within a month, we might just hear a news article says that Avi Loeb has found the messenger or the beacon or the something from another civilization. I really hope that happens, mate.
Thank you.
All right, it's time for today's Shark Bite, where Sierra brings us something cool to wrap up the show. What have you got for us today, Sierra?
Yeah, today I'm telling you about a spot where the ocean drops over 300 feet in sea level.
Drops as in there's a hole in the ocean?
No, not like a hole. They're called gravity holes, but they're actually just gravitational anomalies. So there's this really big one in the Indian Ocean that spans 1.2 million square miles off of India's southern coast.
Okay, and is it like a drop in the seafloor, or are you saying the actual ocean is dipping in?
So it's not like a cliff. It's not like you're going to be looking out at the ocean and all of a sudden you're not going to see the ocean water below you. It's kind of like a divot. Before we had the Himalayas, between these two plates, there was an ocean. So over millions and millions of years, as these two plates came together and collided, it created the Himalayas, but also that oceanic material subducted. And that subduction, they think, created this plume in the mantle that brought lower density material up from the core of the Earth closer to the surface, which caused a change in the amount of gravity, the gravitational pull.
So, but in practice, if you're sailing along, you would kind of be going downhill. Is that what you're saying? Like, if you put a straight edge on the ocean, even though, look, the world is round-ish, it's certainly not flat. But if you were to put a straight edge on the two edges of this gravitational hole, you're saying the ocean would dip out below that, like a divot in grass.
Yes, so you would. So there is a divot, but to the human eye, the ocean is so large and the depth of the ocean, the water column is so deep that you wouldn't actually see it. It's just kind of one of those weird things that you have to wrap your head around.
That is absolutely fascinating. So is that definitely where the aliens are?
That's what I think.
All right, we'll have to tell Avi, right? I mean,
Yeah.
he's probably looking in the wrong
Calm
spot.
back up.
All right, thanks, Sierra.
Yeah, anytime.
That's it for today's podcast. I want to thank you all for listening, and a special thanks to Dr. Avi Loeb for sharing his knowledge about the extraterrestrial and helping me fulfill a childhood dream about being a UFO researcher. Check out his book. It's called Interstellar. It's really, really interesting. Until next time, I'm Luke Tipple. I'll chat to you soon.
You're listening to the Shockwave